Hi guys, so in this video we are going to see about busbar protection, stability in the busbar protection. For this we are going to see this busbar, which is one main and one aux without bus sectionalizer. So there is no CB circuit breaker or CT on the bus sectionalizer. There is only one isolator. Okay, so there are two sections, section 1, section this is section 2, this is section 1, and this is the transfer bus, this is the main bus. Okay, so it is divided into three zones. This is zone 1, this is zone 1, this is zone 2, and this is zone 3. TVC is the zone 3. Okay, so we'll in this video we'll discuss one case about the stability, that is both the bays are on same bus. Okay, and the bus section isolator is open. Okay, so we have shown so this is one bay, and this is the main bus isolator, and this is the transfer bus isolator. Okay, so this is one bay and this is the other bay. Okay, so first case is in the normal condition, both bays are on the same bus section with bus section isolator open, and we'll first see the normal condition. Okay, so remember one thing, that the CT star point is made towards the bus. This is the CT, and this star point is CT star point is made towards the bus. Okay, and this is the second bay. This is there also CT star point is towards the bus. All right. Okay, so the current is going into the bus, and here the current is going out of the bus. In this bay, current is going out of the bus. So if you want to simulate the current going into the bus, in the CT secondary we have to inject a current that is at an angle 0. So the current in the bus goes, if in the primary the current is from P2 to P1, the current goes from in the CT secondary goes from S1 to S2. Okay, so remember one thing, that when the current is going into the main bus, the CT secondary current we have to give simulate. For simulating the CT secondary current, we have to give the current at an angle 0. So we'll give, for simulating the current into the bus, we'll give 2 at an angle 0, 2 amperes at an angle 0. Similarly, when so the current is going into the bus and the same current is coming out, so the current coming out of the bus, for simulating that current in the CT secondary, we give 2 at an angle 180 degrees. Okay, so this is the current that we are going to give, and the differential current ID is equal to the vector sum of the current I1 plus I2. So the current I1 is 1.33 amperes. 1.33 amperes. We'll see later on how the 2 ampere is converted into 1.33 amperes. 1.33 amperes plus 1.33 amperes at an angle 0, and it's minus 1.33, that is angle 180 degrees. So it's coming out, differential current is coming out to 0, and the restraining current is the magnitude of the sum of the two currents, I1 plus I2, it's 2.66. So so in the normal condition, the bus bar won't operate, and so it's a stable condition. Okay, now we'll see the fault condition. Let's assume that there's a fault on the main bus section 1. Okay, so what will happen is, this current will go into the bus, so it's 2 at an angle 0, but this current will also go into the bus, because it's a fault here, it will feed the fault, and so it's also 2 angle 0. So since both are at an angle 0, so they will add up. Okay, the vector sum of them will add up, and it will be 2.66. okay, 2.66, and the restraining current is the magnitude of the I1 plus I2, so it becomes 2.66. Okay, so but the slope of them is 100%, ID by IR is 100%, and so the busbar protection will operate in this case. Okay, alright, so these are the both cases, both based on same bus section with bus section isolator open during the fault normal condition and during the fault condition. Okay, so what we'll do is, we will so in the fault condition, all the bays, we have to note that there should be current in the differential current, and all the bays on bus section 1 should operate. Okay, we should check that. Alright, So in this table we can see the current injected is 2 amperes. Okay, in current I1 is 2 amp, normal condition I1 is 2 ampere, I2 is 2 ampere. Okay, so there is a multiplying factor. Multiplying factor is equal to CT ratio by the base current. Base current is 1200 amperes, 1200 amperes. Okay, base current is we have to keep because there are different CT ratios, so we have to bring them on the same platform. That's why we use a base current, and so the multiplying factor is CT ratio by the base current. So its CT ratio is 800 amperes and the base current is 1200, so it comes out to be 0.67. Multiplying factor comes out to be 0.67. Okay, so the relay current is the injected current, that is 2 ampere, into the multiplying factor, that is 0.67, is equal to 1.33 amperes. Okay, so differential current, so in normal condition the differential current is a vector sum 1.33 and the other one is minus 1.33, to comes out to be 0, and the restraining current is the magnitude, the addition of 1.33, 1.33 is 2.66. Okay, so in the fault condition what happens is 2.2 fault condition, what happens is both are coming into the bus, and so the vector sum is the addition of 1.33 plus 1.3 is 2.66, and the restraining current is also 2.66. So the slope is 100%, and so the relay will operate, busbar protection will operate. Okay, main zone, in main zone everything is 0. In check zone the differential current is 2.66. Alright, so this was the first condition, that both base, case 1, that both bays are on the same section with bus section isolator open. In the remaining videos we'll see about other cases, like say both bus on the same bus with bus section isolator closed, and one bay on bus 1 and the second bay on the bus 2 with bus section isolator open. In third case, the one bay on bus 1, one bay on bus 2 with bus section isolator closed. Then in fifth case, one bay on bus section 1, another bay on the transfer bus. Okay, like that we'll see all the cases in one by one in other videos. So if you like this video, please subscribe to and like our channel, and also follow us on the LinkedIn. I'll provide the LinkedIn profile in the description. Thank you so much.